You've seen it 100 times. A cat slips off the counter, twists in the air, and lands on all 4 feet like nothing happened. Scientists call it the writing reflex. The cat didn't learn it, nobody taught it. And here's the weird part. Mid-fall, with nothing to push against, flipping over should be flat out impossible. No floor, no wall, no launch. Just a falling cat and the laws of physics, quietly bending. So how does your cat rewrite a rule of motion on the way down? Here's the thing. Your cat isn't breaking physics. It's abusing a loophole, and honestly, that's worse. Because the loophole is real, the math checks out, and it still looks like a magic trick every single time. The rule your cat is bending is called conservation of angular momentum. Big words, simple idea. If you're not spinning when you start, you can't just decide to start spinning. Not in midair, not with nothing to grab. A figure skater speeds up by pulling their arms in, sure. But they were already turning. Your cat starts from a dead stop and still lands facing the floor. So how did anybody figure this out? In 1894, a French physiologist named Etienne-Jules Marey pointed an early high-speed camera at a falling cat and shot it at 12 frames a second. He expected to catch the cat quietly pushing off his hands for a head start. He didn't. The cat left his grip with 0 rotation and somehow arrived at the ground mid-twist. The photos ran in a French science journal, and a room full of physicists basically lost their minds because, on paper, the cat was cheating. Your cat has no idea any of this is impossible. Cool, mystery solved. Except it wasn't. Marey had the pictures. Nobody had the actual mechanism. For decades, the falling cat sat there as a genuinely annoying little problem. A thing everybody could watch happen and nobody could explain with a straight equation. It's the kind of thing they promise you in high school physics and then quietly skip. And here's where it gets stupid. The answer showed up in 1969 when 2 Stanford engineers, Thomas Kane and M. Scher, modeled the cat as 2 cylinders joined in the middle. Front half, back half. They called it the bend and twist. The cat folds at the waist and spins its 2 halves in opposite directions. And because they spin opposite ways, the books still balance at 0. The cat never gains any angular momentum. It just borrows against itself, pays the debt back before it lands, and the universe never notices a thing. Let me actually show you the move because it's clever in a way that's almost rude. The cat pulls its front legs in tight and throws its back legs out wide. Now, the tucked front half turns easily while the wide back half barely budges. Then it flips the geometry, back legs in, front legs out, and does the same thing in reverse. 2 half turns that refuse to cancel out. Add them up and the whole animal has rotated while the physics ledger still reads 0 because technically the halves went opposite ways. Your cat did the accounting. Your cat cannot count. So why can a cat do this and you, standing there, can't? Hardware. You've got a collarbone bolted across your shoulders like a crossbar locked to your breastbone. Your cat doesn't. Its collarbone floats free, buried in muscle, wired to nothing so the shoulders swing loose, and its spine runs around 30 vertebrae that bend like a wrung-out towel. You are, structurally, a filing cabinet. Your cat is a rope with opinions. Try the same move off your bed and you'll land on your back with a grunt and a bruised sense of self because your body physically can't split into 2 halves that spin against each other. The cat can. That's not talent. That's just better bones. Your cat has no idea any of this is impossible. But there's a catch, and it's the part nobody puts on the poster. The whole routine costs height. Your cat needs about a foot of drop and a fraction of a second to run the full bend and twist and get its feet down. Any less and it can't finish. So a cat that rolls off a low coffee table barely has the runway. It hasn't got room to finish the trick before the floor arrives. Shortfall, worse odds. Which raises a different, dumber question. If more height means more time to spin, does falling from higher actually help your cat? And here's the part that sounds made up. Vets have a name for exactly this high-rise syndrome, pulled from years of stitching up cats that dropped out of apartment windows in cities like New York. You'd expect a clean, straight line. More floors, more damage, more dead cat. Except the data doesn't do that. In a 1987 study, 2 vets named Whitney and Mehlhaff went through over 100 cats that fell from high-rise buildings, and the cats that fell from higher up, past about the 7th floor, on zones, often walked away hurt less than the ones from the middle floors. Read that again, because it's backwards. The explanation is the twist nobody expects. Once your cat stops speeding up, Once it hits terminal velocity and stops feeling that falling elevator drop in its stomach, it stops panicking and relaxes. It spreads out flat like a furry parachute, splays all four legs, and lands soft across the whole body instead of bracing stiff. A cat that's still accelerating lands rigid and takes it in the joints. A cat that's given up and gone limp lands like a beanbag. Now, don't run the experiment. The vets only counted the cats that got carried in. Nobody logged the ones that didn't make it, so the numbers flatter the survivors. Don't think about that too hard. So here's where we land. Your cat runs a maneuver that took people 75 years in a Stanford model to explain, and it pulls it off in a fraction of a second in the dark, on pure reflex, on the way down from your kitchen counter. We wrote the equations, we built the cameras. We shot it 12 times a second because we couldn't believe our own eyes. And the cat just does it, then walks off like you're the weird one for staring. We're the only species that had to photograph gravity to trust it. Your cat has no idea any of this is impossible. That's the whole trick. Now you know, sorry.